Okay, let's do problem 86 partition list. In this question, we are given a simply linked list and value of x. And if the nodes are greater than or equal to value of x, we push them to the end, and the other ones remain in the front. And when we push the nodes, they should be pushed in the order they appear. So 4 appears first, and then 3, and then 5. So without any coding implementation, it feels like if we have, say, partition 1 here with the multiple nodes, and then partition 2 here with multiple nodes, we can simply connect these two together and then return the head. The question is, how can we populate each of the node, and then how can we link these two together, and how do we find out the head of the partition 1? Well, it feels fairly logical to come up with a dummy node. Say it's dummy 1, and then we have dummy 2. So dummy 1 will be for partition 1, and then dummy 2 will be for partition 2. So we have dummy 1, and this one, so dummy 1 is pointing to 1. Well, let's just do it realistically. So it's pointing to 1, and then we can say that's tail 1. And then this 4, so this is pointing to this, and then we can set this to tail 2. Now this 3, though, now the tail 2 is pointing to 3, and then we are moving tail 2 to the current one, and then this 2, so we can move tail 1 to point to this, and then we can move tail 1. And then we have 5, so we can make tail 2 to point to 5, and then move tail 2. And when it comes to 2, we have tail 1, so tail 1 points to 2, and then we can set that to tail 1. So if I were to redraw this, we have dummy 1 pointing to 1, which is pointing to 2, which is pointing to 2. And then we do know that this is tail 1. And we have dummy 2 pointing to 4, pointing to 3, and then pointing to 5. And that's tail 2. So what we need to do next is connecting this 2 to 4. So what is this for? It's dummy 2 done next, and then this is tail 1, so we can just link them, and we can make sure that tail 2 points to null at the end. So that's the basic logic, and let's write down the code. So we have list node dummy 1 is equal to new list node of 0, and the list node of dummy 2 is new list node of 0 as well, and list node tail 1 will be initially dummy 1, and then list node tail 2 will be dummy 2. And then we're gonna move our so going through each of the nodes, we'll be moving head one by one. So if head is not equal to null, we're gonna do we can do head if head.val is less than x, it should go to it belongs to this partition 1. So tail 1 done next is equal to head, and then tail 1 is equal to tail 1 done next, so move tail 1 pointer, and then else we add that to partition 2, so tail 2 done next is equal to head, and then tail 2 is equal to tail 2 done next. and then we have to move head. Head is equal to head.next. Now everything's done. We need to make sure tail1 points to the head of the partition 2. So tail1.next is equal to dummy2.next, and we need to make sure tail2 points to tail2.next is null. Why do we need to make sure it points to null? Well, after our last iteration, we said tail2.next is head, which is 5. So there is a, and then we said tail2 is equal to next, which is null. So tail2 is null, but tail2.next is pointing to head. So there's an infinite cycle here. So we have to break that cycle, and we just return dummy1.next, which is this value here. Let's run the test. Okay, let's submit. Okay, that's it.